Good morning, Twitch. Good morning, good morning, good morning. We got tinygrad up here. Tinygrad is looking not so tiny anymore. It's growing. And this is a great, no, not comma.ai. Where am I going? Let's go to GeoHot. Here we go. Tinygrad. Look how many stars tinygrad has. 496 stars. If everybody on this stream today gives tinygrad a star, we can have 1,000 stars. And for every 1,000 stars, we can exchange them for a kilostar. Not really sure what a kilostar is, but we can probably get them if we have 1,000 stars. Doesn't that make sense? You know what a million stars is? A megastar. Who likes my stream title? We're going to investigate voter fruad. I'm not really sure what voter fruad is, but we're going to investigate it. We'll see if they ban me for investigating voter fruad. No. What we're actually doing right now is we are going to work on our GPU. Investigation. You know we don't talk about self-driving on this channel. We don't talk about politics unless it's funny. If there's lulls involved, that's always good, you know? You know we like the lulls. You guys know personally, I believe we should abolish governments and replace them with blockchains. So, let's go. So we have, I just got working in my test MNIST. We have a test called Test SGD GPU. And now we are training, we can train an MNIST model on the GPU. Now, the problem with this is it does take twice as long as on the CPU. Sorry, by twice I mean 10 times. So if you like things that are slow, you might want to consider using the GPU in tinygrad. Why is it slower? Shouldn't the GPU be faster? Well, part of it is because we wrote really, really crappy code. The other thing about the title, I mean, I thought about spelling it correctly, but I think that might actually take it too far, and I might actually get banned. You guys know that we are against censorship. We believe in free speech on this channel. We believe in free speech, and we believe in blockchain. Can I back up and explain what tinygrad is and why we wrote it? You know, oh my God, the whys. You guys know about the whys. We don't do whys. We don't do whys on this channel. We only do hows. What a great way to talk about politics. Just imagine all the votes were put in a blockchain. And then there'd be no voter fruad because we just have a blockchain. You can't do fruad on a blockchain. It's against the rules of the blockchain. Replace politicians with toddlers. I like that plan. I mean, what if we just did that? What if we actually made a toddler president?
You have to be at least 35.
Yeah, but what if we made a toddler president? And we really, as a country, tried our best to interpret his wishes?
You can't. You have to be 35.
Well, yeah, but laws can be changed, Alex. Let's elect a 2-year-old. And then whatever the 2-year-old does, we try our best to do as a country. Hey, I stole it from Twitch chat. So yeah, unfortunately it's slower on the GPU, and probably because we're doing dispatches and stuff. GPUs really only get fast. Well, maybe we should write a profiler. Should we write a profiler? How do I manage to always look that good? The answer is blood transfusions from young kids. What? Oh, meth. Yeah. That was that. Yeah. It turns out meth's actually good for you. Wow, they've been lying to you, man. All the anti-meth people, they keep all the meth for themselves. The dentist doesn't want you to know. That's true. Oh, I went to the dentist. Please don't talk about politics. Don't even do it jokingly. Some people might actually believe it. Stop using your voice for, I don't know. Yeah. But they're not a subscriber, so, their opinion has less value than people who subscribe. No, it's not Python probably. It's probably these CL calls, or it's probably really because I wrote these kernels super badly. Okay, so if you guys can be helpful, you want to be helpful? Who wants to be helpful? Let's see what the issues are. Oh, I fixed this issue. Just tell this guy that he has to clear his cache. I don't know who wrote the caching code so badly, probably me. Fun note, you guys want to learn something real? I'll teach something real on this stream. I fixed this while I was in the bathroom at the coffee shop, so you didn't get to see it, but you see how I use this pattern here where I open a temp file and then I move the file into its correct place? If you don't do this, it's very easy to get corrupt files, like where this open will succeed. Actually, this is really bad. This also shouldn't even be in here. Like first you want to fetch it, then you want to write it and then rename. So you do this because it's atomic. os.rename is atomic. Well, obviously open write close is not atomic. So that's why this failed here, because he probably only half downloaded the efficient net weights. So he can clear his cache, and someone should tell him to do that, and then download the latest version. Well, some people just spell things wrong. Many GPU ops are missing. Here's where you guys can help. So you guys can check off log softmax, because I wrote that one this morning. This one should just work right away on the GPU. I don't think that should be a problem. That one should be very easy to write. So somebody can write reshape. Somebody can write pad 2D, conv 2D, max pool 2D, and average pool 2D. So if somebody can do that while we're streaming, I'll write a profiler, and we can start seeing if we can get some speed out of this GPU. So you guys know, tinygrad actually has a few goals now. tinygrad is becoming more real. Every day I pour hundreds of hours into it. By hundreds of hours, I mean I work on it on the weekends with you guys on Twitch for entertainment. So, to do, train an ImageNet on EfficientNet. Make it work, tinygrad work on comma.2 and run driving model. So we don't talk about comma.ai in the stream, but we can talk about it a little bit. So right now in the comma.2, we're using this thing called SNPE. SNPE is written by Qualcomm. It's okay, it's not bad, but there's a few things that are wrong with it. So one of them is I wrote this thing need, which sits on underneath SNPE and just replays the exact same instructions to the GPU driver at the user kernel interface. So this is nice, but it would be easier to do if you didn't have to intercept the calls and you actually just were. Well, the need wouldn't even change that much. But the other thing we can then do is start really writing these kernels. So there's this library in NVIDIA called CUDNN. And CUDNN is part of the reason. Okay, so let's step back. I'm going to try my best to convey ideas. I had some cold brew coffee this morning, so I'm really amped up, boys. But our goal on this stream is to investigate is to take down NVIDIA. Yes, that's true. AMD released these beautiful new GPUs. Now, unfortunately, part of the problem with these beautiful new GPUs is the software is all shitty. But if we could write some good software for these GPUs, if we could just train efficient nets faster on these AMD GPUs than you can train them on NVIDIA GPUs, we can help take a bite out of NVIDIA. And yeah, but okay, unfortunately AMD put them in stupid cases. So if someone knows where you can get a blower fan for this GPU, I'd be very excited. I'd buy a whole lot of them. By a whole lot of them, I mean like just 2, but we got to start somewhere. And then if we can get efficient net training to run faster on these than the NVIDIA. Now, I have a few hopes for this too. When you look, I think it's like Tech Power Up that breaks down the GPU specs. Yeah, this is what gives me hope. So the NVIDIA GPUs have like double the RAM bandwidth from the AMD GPUs. The NVIDIA ones almost have a terabyte per second. By the way, that's a terabyte. So it only has 512. But it has this 128 meg cache. So when you look at this, so let's go to, we'll look at like a 3080. 3080s, I believe, only have 5 megs of cache. Yeah, they don't have an L3 cache, they only have 5 megs of cache. Yet, if I look at the A100, it has 40 megs of cache. So when you're doing a matrix multiplication, like say you're doing a matrix multiplication of like 2, let's say 1024 matrices. So 1024 by 1024, 1024 by 1024. Quick chat, what's the complexity of matrix multiplication? NVIDIA BTFO definitely allowed. N cubed, thank you JD Paul Blart, this guy knows. Zazin said 2, you were close. It's N cubed. Now the thing about it being N cubed is that's compute. So how many accesses? How many memory accesses is it? Well, yeah. You guys want to talk about like what are those things called? Strassen, you can get a little lower, and then there's some papers. But how many memories accesses is it? N squared, yeah. So it's a lot less memory access. O of n squared. It's actually 2n squared. System Strassen's like 2.7, but it's n squared. So there's a lot less memory accesses than there are computes. But the problem with that is if you're doing matrix multiplications, unless you're super cache coherent, you're going to end up, actually I think even if you're not, we can write a simulator for this if we really cared. But my point is, if we can load the 2 matrices entirely into cache and then do the multiply on them, this is great. Now, unfortunately, when you only have 5 megs of cache, you're not going to fit them both in cache if they're float 32. But if you have 128 megs of cache, I think AMD has been calling this the infinity cache. So it gives me hope for this GPU helping to take a bite out of NVIDIA. Now, where does tinygrad come in? Tinygrad is just a very simple way to experiment with, we can experiment with convolution kernels. We can experiment with, you only have to write a few ops in order to get the efficient net to work. And you should also have to write those same few ops to get the efficient net to work backwards. So if we can train ImageNet faster on a single AMD GPU than on an NVIDIA GPU, we're winning, and we can write our own CUDNN. Now, how do we actually do this? Well, so AMD has all these things like ROCm, where they're really pushing down to. They want to like expose, I don't even really understand it, because OpenCL is all in user space. The compiler for OpenCL that turns OpenCL into GPU assembly instructions is all in user space. So we could theoretically just fix all of this in user space, write our own assembly versions of these kernels. We can do the same search NVIDIA does for CUDNN, and we can build super fast kernels for comms and matrix multiplies. And then, this is all leading up to eventually building our own GPU accelerators, right? tinygrad, the officially supported when we make our own Tesla chips, right? But first we should move our stuff over to tinygrad. You're never gonna really get PyTorch. PyTorch is deeply baked in with the with NVIDIA. Like, there's no nice way to plug in OpenCL to it. But if we can get our driving model running in here, we can get it running faster. We can use thneed to sit under the driver. The Python doesn't matter. That completely cuts the Python out. All right, yeah, but a lot of AMD's APIs for ML are just straight up ripoffs of NVIDIA's. If you look at, like, so NVIDIA has this thing Nickel, which does, like, wait, what? Wait, why isn't this working? Wait, what? Why can't I? What's going on? Do I have a broken key or something? What's going on? It's like my arrow key is stuck down. No, I'm not touching the computer. Dude, that was weird. That was weird. Okay, whatever. I think if we got hacked, I don't think they would have held down the right arrow key. Yeah, hackers, you hear that? You're lame. Why don't you go investigate some voter fruad? Okay. Are we gonna have to write those other ops? What did I say we were gonna write? We're gonna write a profiler. Fetch ran out of input fix. Ooh.
Trump golfing is they announced Pennsylvania is iconic.
What?
Chris, you was
He's playing some golfs? Yeah, we can merge this in. Okay. Fast. Slow. I think we just have to, if I write the conv, we can, all right, I'll write the conv first because I do want GPUs to be fast and we can have fun writing conv. GPU should be very good at conv, I think. Okay, tinygrad. Let's first write the test. Tiny combnet. Oh, we also have to move Atom to, well, we'll deal with that later. I wrote my optimizers to operate at like the data level, not at the tensor level. I fixed SGD, but I didn't fix Atom. So if somebody wants to fix Atom, I'd appreciate you. Yeah, that doesn't work. Well, I shouldn't actually need that anymore. See, again, every time I put dot data, it was a terrible hack, and I deeply regret doing it. That should just work, right now? Tuple has no attribute data. Oh, because it's not a tensor. Let me see my reshape. Where do I use that reshape? Do it like that. Should work okay, I think, unless there's other places where there's problems. Shape is not defined. Oh. No, actually, I don't even need to change that. I just need to pass it in as a keyword argument. I think I actually already do that in a few places. Okay, good. Is it faster? It feels faster. Maybe it's just the comms got faster. Wow, that's pretty good. That trains so fast now. All right, let's test GPU, and we don't have a GPU op reshape, so that'll be the first one we write. Then you guys can go into the issue and check it off, you know? All right, zoom in so I can see the monitor. Yeah. Okay. So on the left I have the CPU ops, and on the right I have the GPU ops. When I plug it in, I get tiny electric shocks in my hand. So I think we don't actually have to, I could just say x.shape equals shape. Yeah, the power of GPU. Grad output.shape equals in shape. In shape. Okay. Key error reshape. Did I not copy the register? No, that registers. What? What? Why didn't that work? Oh. Okay. Now the conv doesn't work. I really think it's worth writing a test for reshape. Skip on GPU. Getting comms to work. Whoa. There's a lot of wind. Is chat saying anything good? What is tinygrad, a city in Russia? I like that. If someone fits that as a good tagline into the README, I'll merge it. Putin's got his eyes on tinygrad. Wow, that got long. Okay, so we already have a test for getting convs to work on the GPU. test ops GPU test conv 2D. Key error conv 2D. Wow, the GPU ops is getting long. Oh my god, writing this sounds kind of brutal. Maybe it won't be too bad. Copy all that. Oh, this is going to make tinygrad too large for sure. All right, do you guys know what a convolution is? And then what's our output size to the convolution? Okay. So we will say ret equals buffer new ctx, and then the output size of the convolution, which is bs count that. We'll pass in x and w here. And then this is so annoying. I mean, I guess theoretically we could launch a 4D thing here. Like one for each output, kind of. I'm gonna have to pass all these stupid numbers in. Oh, this is so annoying. Ugh. I'm not even sure that's allowed. I have to pass in all these stupid arguments. What did I do wrong? Oh. Invalid work dimension. Okay, you can't do that. Maybe that? Yeah, okay. Okay, so we're gonna have to do the channels locally. But then our weight matrix is channels out, channels in, height, width. And we're gonna have to pass in all these stupid arguments. We have to make groups work. This is such a pain. But this is how you learn. You'll never not understand what a convolution is again after you write this kind of stuff. Chad, have anything good to say? Gonna fork tinygrad, do it. There's no way to do some of the kernel part. Light of hell, thank you for subscribing. I dream of an economy where anyone can pick up work and go have fun completing jobs with friends. I think you're describing World of Warcraft. How can we contribute to tinygrad? So what's on the to-do list? So I'm implementing the comms right now. If you guys want to implement the pools, that would be great. The pools are great. Okay, let's pass in int h and int w for... We have these get global IDs. So we'll say this one is... No, we almost actually don't want to pass in batch here. Let's pass in that. And then we can have the batch be the loop. We'll say this is cout x, y. Well, cout y x, and we got to pass in oi and ox. Oh, it's gonna complain and be like, you passed in too many numbers. For int y. No, that's not right. Call that big Y and big X, or int Y equals Y, Y less than Y plus H, Y plus plus, no, the other way around. We need a big loop for the batch. Okay. Ac plus equals x sub. All right, so what are the x dimensions? We can compute that. Can we? Out plus b times cout times oy times ox plus p times cout times, wait, no, plus c times oy ox plus x times ox plus x. Is that right? Range 0 to y, range 0 to x. All right, we need to know the channels in. B times sin times, we'll say IY, IX for the input Y and the input X, plus, oh, none of this is fast at all. It's like gonna do all these stupid multiplies every time. Oh. All right, we'll just say offset equals this, and then offset plus equals that. But that's actually less important than making sure that inner loop is fast. All right, you know what? Let's just write it slow and then we'll make it fast. Don't want to prematurely optimize. Then we'll write some benchmarks to make this stuff mad fast. Not yet, okay. Am I doing this right with like the channels and the batches? I believe so, because then I can cache the whole weight matrix in like in that kernel, right? I don't know. C times there has to be better ways to write this. Yeah, strided mem access patterns to prevent bank conflicts and stuff. That seems good. We don't want Yeah, there are great tests. Don't worry about that. Oh. This is terrible. Maybe we don't actually want that. I think doing it by batch is easier. We also have to loop the channels. This is really hard to keep straight. And it's going to be super slow. Okay. For each channel, we're going to accumulate. Going to accumulate how many? We're going to accumulate channel out amounts. But I think we're still going to have to loop over channels in. Yeah, that's right. Wow, these things are so much compute. See, this is why using NumPy is cheating. And here I'm writing it. I mean, this is like writing it in C, except it's in OpenCL, which kind of looks like C, but isn't C. Wait, so the... Am I not doing this right? What's a fixed offset? This is going to be so slow. No, it's not right. And we have to multiply this by the same in the weight matrix, which doesn't have a batch index. So the weight matrix is channels out, channels in, height, width. So we have C times channels in times height times width plus this times height times width plus oh no, it's, I mean, I guess we could say y minus h times width plus x minus width. Oh, that's so slow. Oh, that's going to be brutal. Well, we have a test. Let's see. Bajillions of errors. Invalid operand to binary expression. Are some of those floats? CL program build failure. Oh, redefinition of W because W is weight. Okay, we'll call them capital H and capital W. And then that's really annoying because okay. Subscripted value is not an array, pointer, or vector. That's because I called my input x as well. So we can't actually call that loop x. Just call it ix maybe? No, I already used ix. Oh, this is annoying. Input. And then just for clarity, instead of w, we'll call it weight. And then to kind of complete the, we should call this output. Okay, input, weight, output. If we're clear in our variable names, we're clear in our thinking. Use of undeclared W. Don't use W, use capital W. Okay, that's fine. We just need to add the other arguments. Okay, so we have the height, which is NP32 height. Good, I already called it capital. That's consistent. We have the width. We have C out. We have C in. We have OI. We have ox. And then we have, we should actually just call them this, right? I didn't use like IY or IX or anything, right? IY, IX equals, well, actually I can just put them here. IY, IX equals X dot shape. And then here we can just call this IY. And here we can call this IX. We haven't even gotten to fancy shit like strides and stuff, but we'll get to that in a minute. Okay, work. Well, it didn't work. Why am I not surprised? Of course it didn't work. Look at how complicated this crap is. W and H are well understood. Oh, did you want to, did chat want to be useful? No, chat didn't want to be useful. Wait, you guys can see okay, right? Yeah, you guys can see okay. Cool. Okay. I mean, that is how you do a convolution, right? You know, actually, when we copy things, we don't actually technically ravel them and make sure they're correct. There shouldn't be, we're not doing any like weird group stuff, right? Like that's just a basic conv. Let's check the test. Yeah, groups is 1. Height and width are 2. Batch size is 1. Should all work. All right, we're getting some numbers out. They're just not the right numbers. Isn't that true a lot of the times in programming? You get numbers out, they're just not the right numbers. More of the time you got the right numbers. You know, programming would work a lot better. Okay. This is just because there's no... That's right. Same thing here. Weights doesn't have a batch. We accumulate over all the input channels. Cout, cn, oi. Let's just clean these up a little bit. Okay, it's not failing at the backward or anything. No, that won't even, that will just throw a Python error. No, not right. Okay, it's going to range across these three things. We're getting the global ID. GitHub on my phone so I can merge in some of that stuff. Wow, openpilot has a lot of pull requests on it. So it comes up by default. Let's see if anyone fixed anything on tinygrad. Weird refactor. No, just ran out of input fix. We can merge that. Merge. Git stash, git pull, git stash pop. Cool. Well, this file has changed since reading it. Yes. Okay. What'd I do wrong? Chat, you find my bug while I was gone? If I have some shit code. Yeah, we gotta behave. That's right, behave. That's good. Chat is self-moderating themselves. Try some please excuse my dear Aunt Sally. I didn't push my stuff. I just merged a pull request. So we can look at what that pull request was right here. You know it's good. Look at how long that comment is. You know it's probably good. If there's more writing in the commit than there is changes to the code, it's probably high quality stuff. What? What you find? Not a new mattress, just an up. Just an up or a whole new bed?
An up.
Oh, an up. Okay. I got a little scared there.
What do you mean a whole new bed?
Whole new bed? I don't know. If I play a whole new world on stream, I'm gonna get muted. What if I play a whole new world cover? A whole new world. Let's see if there's a drum cover. That sounds appropriate. Oh, perfect. Love YouTube, man. No, that's copyrighted. Okay, come on, that's 8 seconds. That can't be copyrighted. This is a drum cover of a drum cover. All right. Const float input, const float rate, global float output. We set the output here. We loop over channels out. For each of the channels in. Yeah, that's right. Wow. Wow, convolutions are so much compute. This is just to compute 1 pixel of the output. We really shouldn't call this BS because it's a little confusing. Because it actually ranges to BS. So we should call it B. Big B. Okay, where's the bug? A lot of zeros there. A suspicious amount of zeros, eh? Can I move this down here? I want to do I like want that to show up on the same line. A lot of them are 1 now, so like this doesn't make sense. Like, even if I got a lot of stuff wrong, it should still work because that's 1. Okay. This is where we're reading from in the input. We start at Y and go to X. That might change if there's a stride, but we don't have any stride right now. A very normal convolution. Let's print some shapes. No, we don't need that. That's stupid. That's a stupid to do as well. Okay, so that's our X, that's our Y, and that's our out. Two by 2 com. You know what? Let's even make it easier for people. Let's try this. Let's make a 1 by 1 conv. Does a 1 by 1 conv work? I mean, if you can't even do a 1 by 1 conv right, this crap is really useless. That number's right. Look, we got a number right. Okay, that's the input. And then that's the output. What did I do wrong? Do I have like orders or something wrong? 1128, 1128, 1128. Those should be 1 and 1. And like channels out has something, which is fine. Chat, did you find the bug? Start with a 1x1 convolution. Yes, cool. Good, good, good. We're thinking along the same wavelength. Okay. This one works. These two don't. So many ones. I don't get it. Would some of them work and some of them not work? I guess just creating those shapes, so it's not like they're going to be like reshaped weirdly, so it can't be that issue. Let me just pile up and see all buffers. I could dive in and debug them, but not time for that yet. Hopefully we can still find the bug just by looking. Okay, this literally loops to 1. Oh, this isn't right. These aren't right. These aren't. No, wait, yes they are. It's literally input shape. My pattern is the same, like that matches that. Height, width, height, height, width. That's right. Oh, duh. Perfect. It worked. That's just because the gradient doesn't work. But you see how now we're failing on the backward pass? Boom. Fix that. Okay. Careful reading. Find bug. Oh, all right, the backward passes. All right, you know what? Let's just cheat for now and say forward only equals self.gpu. Good. Okay. Which is the first one that doesn't work? We're doing groups there? I think groups are where it fails. We can print the groups. Yeah, okay. We move on to groups 3, and that's where it fails. So we got to write grouped convolutions now. This actually shouldn't be too hard, though. And we also have to make strides work. But that also should be fairly easy, I believe. Okay. So let's make groups work. Groups mean I have to add another loop here for groups. Yeah, groups just go before. Okay. Instead of cout, we'll call it rcout. We'll say np.inc32 groups. Okay, everything still works except for the grouped one, and that's because we didn't actually write the group logic, which we have to write. Oh, and then we can get rid of all these stupid multiplies. Okay. Well, it's only going to affect, no, it also affects cin. Test-driven development. Okay. For the input, does that depend on groups? Do I have an RC in? No, but weights depend on groups. Cert ctx times groups equals that. I wish I actually truly understood this, and I wonder if anyone really does understand it, or they all just kind of spam program like I do. Probably not. There's probably people who actually understand it, and just I'm not one of them. Okay. Go through the groups. That's good. It's good for the output, but I've heard it's equivalent to two convolutions being placed side by side. Yeah. So we actually want that input to be like mod groups or something. Because this isn't, you can't do this here. We'll just write it here. Or actually, I don't even need that. Just do it there. All right, arson. Arson. Arsout, arson, sin. Okay. So for the weights, I believe we still use sin. But for the inputs, we want to use arson. And then we want CI to be modded groups. Can I do mod? No, it shouldn't be modded groups. Maybe it should. Because the normal number of groups is 1. Sure. Okay, well, we know the input here. We know that arsin has to be correct. Like, is this how everyone does this with like dimensional analysis, or do they do it with thinking? But then this can only go up to arsin. Oh, we want to modded arsin, not modded groups. That should be right now, I think. I should have committed the one that kind of worked. No, wait, it still kind of works. Never mind. Gene groups. C, arsin. That doesn't. Well, no, wait, no. There has to be something we access only as part of groups. Oh. I think actually, wait. If we just make that go to arsin. And then here, channels times, wait, is it, the weight is, okay. Here, this shows the right weight reshape. Groups, RC out, RC in. So that C is an RC out, and then here we just multiply G times RC out, RC in, wait, times C in. Ugh, so hard. And we're gonna have to rewrite this to not, do all these multiplies. Terrible. G times RC out times C in times H times W plus what ranges to RC out, which is C, what ranges to C in, CI. Still think this might have to be mod arsin then. No? Look at how many numbers match. It's a lot of matching numbers. We're getting close. So this is basically just looping over the weights, which is nice. Groups, RC out, C in, X, Y. So we just go over the weights like that. And actually, I don't want to change that. I mean, we could change it to not subtract there, but it's fine. Okay, so let's think when the groups is full, RC out is 0. Look, the numbers are so close. The numbers are so close. It's probably just one that doesn't match somewhere. C ranges to RC out, so that's a correct access. I mean, actually, it looks like we're just accessing the weights one at a time, right? That's nice. That's convenient for when we want to actually write that later. We can just change the pointer. Okay. For the input, the only sketchy thing we're doing is this. CI times RC out. You guys find the bug? You think you're having problems with your GPU? No, not all the GPU tests passed yet. You can fix them. No, we're not actually investigating voter fruad. That's a joke. It's a joke. Wearing clothes on stream.
I close. They're just like nude color, so that's for me to see me. You want green tea?
Oh, yes.
We're gonna do yoga.
You do yoga when you calm? You calm.
What?
You know what's going to be fun? I'm not going to write the backward pass because that sounds brutal and terrible. We'll just do a raise exception. We're going to try to get EfficientNet to run on the GPU. Not implemented. We are going to fix groups, though. We got to fix groups. And then we can just work on making this fast. That sounds fun. Fast sounds fun. Watching me debug my loops being slightly wrong. Thank you. Sounds terrible. I've heard groups are equivalent to having convolutions side by side. Oh, okay. So maybe this actually only goes to arsin. No. Because the weight is that. That just means that I reuse different weights for the same inputs, which is exactly what this should do. Or are the numbers wrong? Those look the same, right? Oh. What's my input size? Oh, I might just have to do BS groups sin. Let's write these out and then this will help. BS, the output is groups RC out OI OX. Yeah, so if my input is really, is that right? No, that can't be my input. So we're getting arsin up there. How is their input that? Oh, what? Times equals arsin? What? That's crazy. Oh, I shouldn't have called it that. Oh, well, that was because I named it stupidly. I don't even need that. Yeah, oh, this was stupid. God. Chat, you could have found that. Now if we just type groups times sin times iy times ix. And now it doesn't work for even anything. Because instead of groups, we need to do G. And now it works for all of them. Boom. Tinygrad does forward pass comms on GPU. Cons. I don't think they're cons. I think they're comms. Oh, someone wrote a convolution without loopity loops. So we don't have any loopity loops either. Someone came in and removed the loopity loops too. How many people do we have right now? I can't see. You will not win self-driving cars. Why do you carte? Yeah, why do I carte? It's a nice hotel. Is he doing this just for an exercise? No, I'm doing it because I'm convinced I can write a better convolution than other people, and I'm deluded and I have ego issues. That's why I'm doing it. What does POG mean? You guys, this is Saturday. This is kind of fun, you know? It's not like real software engineering where you have to it's just real software engineering is painful. Writing slow convolutions is fun. Oh yeah, I'm glad you like Metamorphosis and Prime Intellect. It's a good book. It's like a Huawei Mate 10. Oh, POG is good. All right, cool. I don't know what bitch CV is. Okay. What are we still missing now from being able to do our efficient net on the GPU? Let's just try to make an environment variable. If we'll say GPU equals os.getEnv, GPU none is not none. Perfect. When we load in the weights, we'll say if GPU mv.cuda underscore, and then all right. Does our example work on the GPU? That'll be where we end the stream today. I think we're going to have to write the other things too. I think we're going to have to write a pool. Oh, we're going to have to make strides work. I didn't test strided convolutions. Okay, we'll make strides work. We'll do that now. Python 3 test ops. Oh, so slow. Brutally slow. Oh, that's so slow. Okay. Not equal to tolerance because we didn't test strided convolutions. This should be very easy to fix though. I think I just have to add in a few multiplies and we're good. That all stays the same. Yeah, I just need to, if I just multiply these, I think it's fine. And I don't multiply them for the output. What do we want to call them? Yeah, ys, xs. And then, yeah. Well, how exactly do I do this? I think actually I just change these. Okay, cool. We'll have to put in that same, oh, that was really easy. We'll have to put in that same forward only for the GPUs. Perfect. That one was easy. That one was a gimme. Okay. We haven't written max pool 2D or average pool 2D yet. But after we write those, all our ops will work on the GPU except for backward convolutions because nobody wants to write that. Did anybody write it? Do we have a pull request for it? Oh, you guys are making me so happy. Is anybody writing it? Who got my pools working? Pools should be so easy to write on the GPU though. Real software engineering is a lot of politics. Hacking shit up is anarchy and fun. I agree with that. But I didn't close the pool. It was not me. It was not me. I did not close the pool. Yeah, backward conv is just a conv with some tricks. So who wants to write it? You tried with the pools. All right. How many people are watching, by the way? Did you guys tell me? Oh, 751 people investigating voter fruad. Just so you guys remember what it does, it downloads an image of a chicken and then tells us that it's a hen. That's right, don't misgender the chicken. Okay. Create buffer failed, invalid buffer size. What? How could my buffer have an invalid size? Is it too large? Is that the problem with my buffer? Is it too large? We fix strides. We'll get to where pools don't work at the end. I don't think we pool for a while, actually. So we can at least run a lot of things and see how slow it is. Why is my buffer a bad size? I made a good buffer, I promise. tinygrad, no, tensor. That's it. CUDA, where do I do the buffer? Zero. Oh, we can't make zero buffer size. What has a zero buffer size? What even is that? This seems like more of a bug in the example. Oh, num batch is tracked. even have that? Did I put that in my batch norm? Oh. Tensor zeros 0. That's a tragedy. What if I make it 1? We need 1 0. There we go. Now it works. ND array is not contiguous. Well, that's a different problem. Can I ravel and then unravel? Yeah, let's ravel the data. Who's ready to ravel it? I knew this was going to be a problem at some point, and it's because I'm transposing things. Self.data.ravel. Yeah, ravel. Oh, we got to write pad. Oh, we didn't write pad. Who didn't write pad? No one wrote pad.
Rude.
Pad. Let's commit that. That was good stuff. Good. We made good progress there. Unlike staring at those stupid convolutions forever. Fixed strided comms. GPU mvar for enet. Good. You know, we all struggle with the same shit, you know? I hope that watching this channel, you guys can know that this struggle is real. And yeah, you know, it's no one just is like able to, anybody who can just like seamlessly do things has done it before. Right? The whole point of programming, the whole way you get good at programming is you struggle. You struggle enough, and the struggling never goes away. It just gets faster. That's a BoJack Horseman quote. You know that scene where BoJack is running and he runs next to that guy? And BoJack's like, does it get easier? And the guy's like, no, you just go faster. Or actually the BoJack scene's not like that, but I've heard that before too. The BoJack scene is it gets easier, but you have to do it every day. And that's true about programming too. So, you know, watch BoJack Horseman. We're drinking some Rishi green tea, courtesy of Alex, who's over there doing yoga. I solemnly swear I did not hack the election. I'm a supporter of election security using blockchain technology. And if you'll invest in my election blockchain startup, we'll be overthrowing the government in 10 years. Get in early. We'll do favors. You donate to my blockchain campaign, and we will make sure that if you want fracking, we'll do fracking. You don't want fracking? No fracking. Guess what? Blockchain. Kanye chain. Where can you invest? Just send Bitcoin to the following address. All right, who wants to write pad 2D? That one should be easy to write, right? Oh, it sounds brutal. There's np.pad. Look, nobody wrote the backwards passive pad either. We want like GPU mem copy, basically. Well, until we write pad, it's not going to run, so I guess we just got to start doing it, you know? Sometimes that's what you got to do. Okay. First, we want to allocate a buffer. And our buffer size is, let's get this right, X, well, we can just do, where's that? Copy that from conf. BS in IX plus padding 0 plus padding 1. Is that? I might have gotten that backwards. Doesn't matter if I got it backwards. I think it's symmetric anyway. Padding 2, padding 3. Now we need to mem copy a lot of shit. Yeah, we'll do it with a kernel. Wow. How long before this grows to be too large? And we're going to have to change the 1,000-line rule again and be like, well, it doesn't count for GPUs. Cheating. Damn, people are out in the streets celebrating, boys. Input, global float, output, prog, pad 2D, we want to launch it on BSN IY, that's right. Copy some of this from the conv. Say B, C, Y. np.in32. Oh, if we make a new buffer, is it zeroed? I bet it's not. Which what? Oh.
I'm starting a movie club. We're watching all the band films.
We're watching what?
Band films.
Band movies.
Yeah.
What's a band movie? Can we discuss it on Twitch, or is it not allowed?
This one sounds insane. It's from 1969. It's called Pattern of Evil.
Yeah.
It was banned from entry into the United States.
Ooh.
It's made in the UK.
I thought we have freedoms in America.
No, that's what this whole book is about.
What? Who took away our freedoms? Who took away? Was it the communists?
What is a movie about the life of a stripper?
Was it the anti-communists? Who took away our freedoms, Alex? Who took away our freedoms?
It was refused admittance to the country by the U.S. Customs Bureau on the grounds that it was obscene, and proceedings to forfeit the film commenced. There was a trial. The importer moved to dismiss the proceedings against the film.
How long before?
Obscene was unconstitutionally vague.
How long before harassment architecture is banned?
I mean, and, the film forfeiture trial was held, but a jury found the film to be not obscene.
There was a porn guy, Max Hardcore, who got in trouble, like modern. I mean, I'm always interested in what the modern obscenity is.
There's another one that was banned in Atlanta. It was a film about lesbian lovers in the 60s. And in Atlanta, the Georgia police seized the film at the theater. We had a search warrant. I mean, it sounds funny now.
Sounds, yeah, it's funny, but no, I you know. Oh, I don't actually need BS ever. I can't believe I have to go to this much effort to write a pad. Well, you know, we live in the era of Pornhub, so good luck censoring shit. Sex positions married people prefer?
Yeah. Oh, this one sounds good. It's called Computer Game from the 70s. A sexual maniac makes use of a computer dating service to lure women to his home, where he puts them through autoerotic and lesbian activity. The police catch up with him and terminate him and his victims of drug and other practices.
Are we allowed to discuss this on Twitch?
I think we can talk about film.
Can we discuss voter fraud? I think that's the modern obscenity. It's banned from Twitter.
Wait, it's banned from Twitter?
Yeah, try to search for it on Twitter. You can't. You can only search for the misspellings.
Oh, God.
They banned it from the search. Yeah. Oh yeah. Yeah. Welcome to. You know what the worst part is? That almost convinces me. That there's some truth to it. You know. That's the problem with censorship. Like something could be really stupid.
All sexual.
Well, something could be really stupid, like a picture of, Barbra Streisand's house. But, if you ban it, let me see the banned shit, man. I want to be cool. Come on, show me the banned shit. That's how I feel, too. I love banned shit. Really? It's taking this long to write pad? This is pathetic. We're gonna have to write a test for pad. Oh, this is pathetic. I'm a terrible programmer and I should feel bad. No, that's out pointer. We're just literally trying to add some zeros around the image, but they're not gonna be zeros and we have to make copies, which all right, we'll do it with kernels, but we won't be happy about it. Boy, x, y times ox. All right, and for this one, it's b times sin times y, yeah. B times y, c. I should just copy the line below it and then just use that again, but I didn't do that. And then we want to know the size to copy. The size is just ix, and then we can just say output sub o pointer plus x equals input sub I pointer plus x. Is that going to work? I don't know. Let's write a test and find out. GPU equals true. Oh, I actually have to pass all these things in. What? Oh, well, shouldn't mention that on Twitch. Twitch doesn't like edgy. That's what I've heard. Banned movie stream? Yo. I think you can search for it. I think just the autocomplete doesn't work. Yeah, probably I stream for a bit. Know what you want to do? Oh. Yeah, I'd get lunch at like 1.
Yeah,
Yeah, that's okay. Oh no, wait, batch normalization. No, that should just work. That's implemented. If we implement all the ops, it should just work. Okay, let's write a test for our pad. All right, we're gonna listen to a band song.
What is it?
No, it's not a banned song. It's just copyright. Copyright is new censorship. Okay, forward only equals true. Okay, it works on the CPU. It does not work on the GPU because it didn't make zeros. Well, this doesn't work at all. Really? I can't even write pad right? Ah, don't multiply it by an ox, multiply it by an x. Did one of you catch that? I'll be proud of chat if someone caught that. Though you remain determined to be opposed, admittance requires no qualifications. It's where everybody's been and where everybody goes. Buffer new. We want to zero the buffer. Can we zero the buffer? You guys hating on my music?
Rude. Really?
Hating on my music, you know? Is there a flag to zero out the buffer? No, of course not. That would be nice if there was, but there is not. Oh, wait, I didn't actually write the padding. Yeah, we actually have to do the padding here too. So it's not just y, because y is an iy. We have to add we have to add py here, and then here we have to add px. You guys pay attention to how I'm coding badly. Catch my mistakes, and I will be proud of you. All right, so now the only problem is the fact that it's not zeros. Those aren't zeros. They should be zeros. Well, I'll just copy it from the other guy here. Read on copies, host buff equals np.0 shape dot data. No, just that should work. There we go. Boom. Wow, that's a lot of code for a stupid padding up. Boom. Oh, this isn't even going to run at all. What am I thinking? It doesn't have any broadcasting. How many of these things actually use broadcasting? Oh, they use broadcasting. Oh no, batch norm uses broadcasting. Oh, that's a tragedy. Oh, that's a huge tragedy. Oh man, nobody's gonna write that shit and make it work. Oh, what a tragedy. You know what broadcasting is? Yeah, exactly. Exactly. Look it up and be sad. Subjective based on how much they like you. No broadcasting. Okay, well, how much do I actually have to write? Oh, I think some of them are just silently wrong too, which is even worse. All right, let's just comment out the batch norm stuff for now. Okay, now we're back to just not having pool. Wait. Oh no, that's okay, that's never mind, that's high up. Oh, even when we add the biases, it requires broadcasting. All right, well, the good news is we probably only have to write it for binary op. You know, guys, like we can complain about it. The thing about complaining about it is that doesn't get any code written, so let's just write it. That's right. Are we failing the too many lines test yet? Nope. Still passing all the tests. Okay. Should have checked it on the computer so you guys could see, but I checked it on my phone. Yeah. Alienware, thank you for subscribing. I'm glad you guys all learned what broadcasting is. Place cropping by seam carving. All right. What's the elegant way to write broadcasting? Is there an actual elegant way? Should we do research or should we just try something? It has to do with like strides and stuff. We should assert. Oh no, they shouldn't. They don't always have to be the same size. Let's see how many of our tests fail that. And those are probably the ones where yeah, things like quick hack for fail, that's okay. We're allowed size mismatch there. Okay, that might be the only one. You guys, I'm still waiting on somebody to write the pools. Open the pools. All right, let's just hack something for now. Where's my binary op? Wait. Oh. Oh, look at that. We enabled really stupid broadcasting and didn't test it well. Oh, look at our crappy broadcasting we wrote. It's probably to make like mean work or something. Wow, who wrote this shitty code? Look at this. So shitty. Yeah. So negative dimensions are not allowed. Should probably change these to be GO, GA, GB, like Gibby. Actually, this is so stupid. Why am I even writing this? Okay. What we want to write actually is something that gets the, so we'll say float A equals that, float B equals that. Yeah, okay, now we're talking. And now we say res G sub that equals ret, float ret. Okay, and now we can just change this to stuff like, you know, ret equals, actually, we should do better than that. We don't even need ret here. We could just say A plus B, right? Oh yeah, look at how beautifully clean my code is. Yes, now we are talking. That should work. I think. I don't think any of our reduce ops are more complicated than that. Or any of our binary ops, right? That's not a binary op. It's a unary op, but we can do the same refactoring. Oh, I wrote stupid code. Yep, this one fits fine in the paradigm. How A comma B. Oh my god, this was really bad. All these stupid GIDs. Ugh. Refactor. Huh. What?
Okay. Reva scratched Tom's Lamborghini. He let her drive it. He's not a driver's license.
Wait, Reva scratched his Lamborghini?
Yeah.
Uh-oh. Sounds like a bad time. Wait, did she crash it into something?
I know she like scratched him up against something.
So she hit something with the Lamborghini.
All down the side, sure. We're driving the Lambo in the car park and we scratched it all down the side.
Wait, is Tom in the car? Does Tom know? Oh my god.
Maybe Tom would let her alone unsupervised in the car.
Dude, I don't know.
That's not fun.
Do you see what our refactor did? Now, how many things did I break? Probably a lot. That's the problem with refactors. But that's why you write good tests. Okay, test sub is broken. Probably only on the backward pass. No, that looks like not the backward pass. We don't even need a wrap. We can just do res g sub gid equals code. Okay, none of these ops work. Oh, well, no, none of the ops work, I think. Well, okay, we have to fix that. The thing is, if you don't fix some, everything else looks broken. Okay, we're making progress. That's good. 1 minus XA. Oh, I changed it for a unireop by accident. We should probably fix the unireops too. This was stupid how I wrote it. So you see what we're changing now? We are making... Instead of the ops containing all this fancy looking code, the op now will just operate on a single element. And then the wrapping function will take care of the rest of it. Okay. Aside from things that are not implemented, we're good. Refactor ops to prepare for broadcasting. All right, I think there's a really cute way to write this, but I don't know it, unfortunately. Oh, you made a try with pools. Woo, good job. All right, let's see what we got. Does it work? Did you write a test, and does it pass the test? Does it pass test on GPU? The Simpsons, thank you for subscribing. Did you pass the test? HTTP less and RO. What? You didn't pass the tests. You passed test, I merge. Right average pool too. Actually, take a look at how I implemented. Oh yeah, you're on the right path, totally. Let's see. Input rows, out rows, calls. Well, this isn't right. This is what your global IDs are going to be, right? So you're getting 2 global IDs and you're only passing one thing in here. So I don't think you want to do that. Like, this is the argument of the number of kernels to launch. In fact, yeah, you probably just want, if it's just input rows and output rows, you're probably good. Yeah. I also think you don't want to pass in that twice. You got to support, yeah, so you have to support kernels that are asymmetric, not just symmetric kernels. This isn't right. You got some work to do still. And then also take a look at how I did it in test ops, and you can see that like average pools and max pools are very similar. So just write like some shared code that shares between the two. And now let's try our best to write broadcasting. Let's not call these. Oh, stupid craps. Okay. Ugh. Okay, cool. Oh. Yeah, okay, we have to fix reshape there too, because you don't actually pass in that -1. You do nails?
But I'm going to go do them.
Oh.
I'll see you in a little bit.
Yeah. Asymmetric kernels. My chess engine was good enough to beat me, so probably like a 1500. I could beat it sometimes, but if s equals -1, we want it to be the sum of the rest of them. T sum 0, T sum plus equal, no, times equals s. This is really crappy, but fine. Oh, sorry. What? Oh. No, yeah, that's not right. No, none of this is right. Okay, good. How we doing on peoples? We got a lot of peoples? All right, does everyone see how to broadcast? What we're gonna have to do to broadcast. The problem is these shapes don't match, yet you can still add them up. All right, maybe we just write some hack shit. Hack shit's like, All right, who knows how to write broadcasting? We're getting close. I can't believe I'm actually writing this. The problem is GID isn't actually correct. You know, you can't just take things like -1 for granted. You actually got to write the code for it. Now, really, you have to check that there aren't two -1s. Yeah. Oh, someone made a better max pooling. Oh, what do we got? What do we got? Did you also write average pooling? Oh, now we're talking. Ooh, subsample up. Ooh, fancy. Do the tests pass? Oh, this will be great if this just works. Oh man, Ryan Neff is good, and we're gonna merge this one in. All right. Well, see, I worry a little that you didn't pass the tests, because if you pass the tests, then yeah, they don't pass. I guess they pass enough. None type has no attribute CPU. Okay, let's just do that. You know what? Good enough. I mean, that's passing the forward pass. Cool. Good job. No, the code is good. I can tell already it's good. Oh, this is some nice OpenCL code. Supreme confidence. All right, we might actually get this to work. We just need to write broadcasting. And right now, I think we only need to write very simple broadcasting. Let's write something very simple for now. Oh no, I didn't mean to do that. I just deleted, no. Sorry, we have to rewrite that. Let's write a test. Got to spell true right. You know, I was in a spelling bee once. It was a true story. And the word was Maine. And I was like, could you give me the definition? And they're like, you know, because you got like the Maine, which is the new lame thing that they call things instead of master. You got like a lion's mane. You also have the state of Maine. And they said the definition was the state of Maine. So, you know, I knew how to spell this as Maine. And they told me I was wrong. And I'm standing there on the stage. I'm like, you guys stupid? Maine. Now, who knows what I did wrong? That's right. It was capital Maine, and that's what I get for not reading the rules of the spelling bee. And I was kicked out of the spelling bee on the first round, and I never went to a spelling bee again because I was like, these things are really stupid. But actually, this is one of the things where I should have realized that I was in the wrong, and I should have understood that I should have read the rules, and I was only hurting myself. All right, let's check my broadcast ads. Passes on the CPU, fails on the GPU because my binary shape mismatch. Cool. Okay. We wrote hacked broadcast. Binary op, shape mismatch, and div. Oh, because we're adding EPS. Okay, that's fine. That one's okay as well. We can add a special case for that. Invalid arg size, eh? That should be fine. Wait, that shouldn't be 1. Oops. be that. Processing argument 2. Processing argument 2, 1 based, invalid arg size. Oh, huh? This is some like stupid crap. Like, add EPS and it like doesn't work or something. Tensor self.eps, so that should work. Oh, yeah. GPU equals so yeah. GPU equals x dot GPU. That should work. That should be an okay mismatch. Length of Y shape. Oh, it's the other way around. Oops. Okay. Not too bad. There has to be a nice generic way to write this that I just don't know. No! Wait, does that work? That can't work. This is a bug. This is a bug in my efficient net that I guess was just hidden by broadcasting. That can't be what we want, right? Oh, this is going to improve the efficient net on the CPU as well. So that just seems like a bug, right? X squeezed, okay, let's print some shapes. Oh, does your average pool only support 2x2 average pool? No, average pool has bug. You write bug. Oh no, only 2x2. Need to support more than 2x2. Ryan, I should have read your code. All right. Before we blame Ryan, let's make sure that I didn't do something stupid. Okay. Max pool 2D, kernel size. Okay, kernel size being passed in here. Whoa, uint2, kernel size.x. Oh man, this stuff looks good. Yeah, but why'd you do this? Well, you can't just divide by 2 like that. You have to divide by the kernel size. Why you right? You can't just divide by 2. You do so good, but you divide by 2. Oh God. Oh. Wait, so technically those are actually different things. One of them's a kernel size and one of them's a stride. Oh. Well. I mean, it's not exactly a quick fix, and it really makes me think about It really makes me think, you know? I think they're separate things. Yeah. Like, it's not even wrong, it's just the stride. Oh, the default value of the stride is kernel size, though. So first, let's fix test. Wait. And now, if you'd only written this too, you would see it fail. Oh, see, you just assumed that because it got to all the forward passes that you were home free, but that's actually not true. I believe we can test ops now and it's fine. Wait. Oh, not forward pass, forward only. So the first test passed, but the ones afterward didn't. If we test ops GPU now, by the way, the comms are a ton faster on the GPU. You see that the shapes no longer match. Tricky. Some broadcasting test is fail. Pool test is fail. So this hard-coded the stride to be 2. All right, let's just say px equals kernel size. Easy fix. Okay. Ryan, you wrote very good code. And I think it'll even work if someone wants to implement the stride argument, which someone should totally do. But we are back in business. Let's take a look at a chicken. All right. Now let's run it on this GPU. Let's go. Ooh, so fast. So fast. Okay. Our assertion of the shapes being the same is wrong now. Oh man, that's fast. Oh, look how slow the CPU is. Yeah, that's right. Virgin CPU, Chad GPU. Let's go. Okay. We're so close. I think it's even going to work because we got all the tests to pass and everything. And this might actually be the fastest, easiest way to run an efficient net on a Mac. Oh yeah, Chad GPU, so fast. Okay, let's fix this last bug. If raise exception shape mismatch in binop that code x dot shape y dot shape. Yeah. Let's see. Shape mismatch in a, oh, that's fixable. What am I doing wrong there? Oh. Well, that's just a bug in my efficient net. I can just fix that. Dot reshape 1 minus 1. Oh. Oh, yeah. That really make my, oh, I didn't have to broadcast because now it's actually the right size. Oh, that's great. Okay. Now the only problem is that this is on the CPU, so we just have to do dot CPU there. And is it also a hen on the GPU? Whoa, it's a bow. Yo, it's so close. It's just a bow instead of a, you know. On the CPU, it's a hen. But on the GPU, it's a bow. And it has a really big number. It's very convinced it's a bow. Okay, which of my 30 ops is wrong? By the way, that is the picture of the hen that we're doing inference on. I mean, it didn't pass the tests, but it kind of passed the tests. Like, the problem was the test stops as soon as a backward pass fails, and it didn't get to the larger kernel sizes in maxpool. But it was very clean code, and that made the bug so easy to fix. Okay, so the GPU is only double the speed of the CPU, but it's so fast at those initial conv layers, I have so much hope for it. And actually the reason for that is because we're doing the channels. You want to make it fast? Let's just make it fast. I don't like slow. Who's done with slow? This guy. Wait, so all the tests pass. I don't understand why my thing is wrong. Look at all my tests. They all pass. So good. So good. Test pass. Why does that not work? All right, let's make that fast, first of all, because I hate slow. Who else hates slow? Slow, 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 slow. Groups. Oh, actually, I can just do this, right? Can I? What if I just say times groups? And then instead of a loop for groups, I say int g equal this is divided by groups. And then this is mod groups. Get rid of that loop. Now we can dispatch more. Okay, is that fast? Well, it's correct. Let's see if it's faster. I think it's slower. We really want channels to be in there too. Could we just do that? That works, right? Oh my God. It just ran in 0.22 milliseconds. Oh yeah. So fast. Who loves speed? Look at that. The GPU is now 3 times faster than the CPU. It still gets the wrong answer, which is a little bit concerning, but it's so fast at getting the wrong answer. Ah. Fast is greater than correct. I agree with that. Okay, so we're getting a bow. Why are we getting a bow? Did we do something stupid like not convert the image to a float or something? No, we converted the image to a float. Let's take a look at the outputs. They're just like a different order of magnitude. I'm suspicious of my broadcasting code. Oh. I know what I did. The ret buffer is the wrong size. The ret buffer should always be the larger one. Yeah. Oh my God, it gets a hen. We did it. Yeah. Fix broadcast bug. We'll put a lot of G's on bug. Oh, yo, that is the fastest ImageNet inference probably ever on a MacBook GPU. Easy. Easy. Yo. Who's riding with I? All the honking people. Clear it. All right, 23 seconds. Let's try to go even faster if you can believe it. If you can believe it, I think this GPU has a lot more speed to give us if we do some of those multiplies less stupidly. Let's also make a few changes to the README. Now I think every op is implemented. Not all ops are supported yet on the backwards pass. That's good. Pro tip. Set GPU equals 1 if you want this to go faster. Environment variable. Just make sure. Cool. No, I hate when I do that. I press some combination and then my dock stays there, and I hate the dock. Dock, get, BTFO. There we go. All right. We're at 0.24 seconds. I believe that we can go even faster if we clean up the conv a little bit and not stupidly do all those multiplies every time. Does this just work if I say like W pointer equals this? And then I change this here to W pointer and I say W pointer plus equals 1? Does not work. Oh, because we can't do CI. Yeah, that should be okay. Okay, cool. How is that slower? I don't understand. How can that even be close in speed? I got rid of so many multiplies. We want no bugs, so we write less lines. That's a good point. How good is this optimizing compiler that this doesn't matter? This must be so good. It's literally slower. Okay, so maybe a little faster? That's not right anymore. Spatula. It's not even faster. This is stupid. I mean, if it's going to give me the same speed writing that, that's a lot more easy to understand. It gives me the same speed. Optimizing compilers are so good. All right. I don't know. I kind of think that's the stream. We got all the GPU ops implemented. Thanks to Ryan Neff for coming through with a beautiful max pool while we were live here on stream. Ryan Neff, did I say it right? Ryan Neff, yes. You can try shifting loops around. Yeah. I can start playing with L1 caches, but if we're down in the L1 cache land, CPU, 0.73 seconds, GPU, 0.23 seconds. So fast. Okay, I think what we're going to do on some other stream is we're going to see if we can figure out how to get both OBS and tinygrad to look at the camera. I mean, maybe we could just do it. Let's. You want to just do it? What time does Alex get back for lunch? Let's just look quickly and see if this is easy. CV2 open webcam. No, it's going to be like, no, but OBS already has it open. We can't do it. If this doesn't work, we're not doing this stream. Whoops, wrong Python. Oh, but it's going to be like, import CV2. You don't have CV2. Oh, I do have CV2. Sweet. Oh, does this just work? No way. From matplotlib import. Oh. What is it? Import matplotlib as PLT? PLT.imshow? No, it's like something else. It's like import matplotlib.pyplot as PLT. PLT.imshow, PLT.show. Oh, look, it's a picture of me. Yo, who's ready to feed that into the efficient net? Oh, this is going to be so good. Yo, we can hold things up and see what it says it is. Yo, this is going to be great. Let's do it, boys, right here, live on this Twitch channel. Oh, this is going to be so good. This is going to be better than finding all the voter fruad in the world. If you got duped by the title, you're a sucker. Oh, yeah, all right. Big brain shit. Let's go. Pre-process image. All right, let's. Infer image model. Anything else? Probably not. Let's say model image. Time is not defined. I think we can actually get the labels outside. We don't actually use this here, do we? No, we don't. Okay, cool. Let's not do the micrograd puppy anymore. Let's say let's get rid of that. If URL equals webcam, import CV2. All right, what is that? Wow, CV2 just worked. What a crazy world we live in where CV2 just worked. while one out equals infer model comma frame. Does this work? Who thinks it works? Oh, we gotta start it with webcam. And using the GPU. Oh, now we're gonna find all the memory leaks in our crap. Frame equals np.array frame. Print frame.shape. Int object is not. Oh. What kind of image is that? Dot resize. Oh, I guess I want a pill image. Image dot pill image from NumPy. Image dot from array. I knew it was something like that. Okay. We should also probably display the image. There's not an easy way to do that. Oh, we can display one image. It's pretty good. Why am I a lab coat or a payphone? I think I might have the order wrong of the channels. Kill all IPython3. Oh. Perfect. Bye-bye, Python. Yeah, I think we have to do, maybe just this works. It's BGR, we gotta go to RGB. I know it looks the same, but. Yo, I am not a screwdriver. I am not a popsicle. Stop this shit. I'm definitely not an oscilloscope. Why am I not a person? Does it not know person? Maybe the GPU inference doesn't work. I'm not a crossword puzzle, you know? Lab coat. Ice lolly. Lab coat. Payphone. Okay, I somewhat see where it gets payphone from. That's the most legit one it's tried so far. Let's, before I do that one, look at image. Low level pre-process. Okay, that's working. We have the webcam working. Do you guys know if there's any way to not wait? Block equals false. I do worry that that's going to create a million windows. Or no windows at all. Draw. Oh, I think I only have to call show once. Yeah. Oh, ion mode. I see. Great, so if we go to ion mode, we just get nothing. Okay, that's very clearly a picture of person, right? Is person in ImageNet? Sweatshirt, okay. Okay, I see where it's coming from. I don't even know what a mortarboard is. Try holding up a chicken. Good point. Okay, let's try holding up a spindrift. Coffee mug. Ooh. Sunscreen. Okay, all right. Let's hold up an iPhone. Coffee mug. Notebook computer. Car keys? Meat cleaver, barbershop. Not too bad. How about a shoe? Weird stuff in Alex's house. A punching bag. Okay. Do we see where it's coming from? Let's try my wallet. Punching bag. Wait, ATM because of the card. Oh, I see. The picture is not actually, yeah. It's off by 1. What's this? Oxygen mask? How about a real mask? Face diaper. Bath towel, not bad. Yo, what do we think? Let's try a hat. We got a hat here? Bath towel. Whoa, cowboy hat. Oh, it just gets it wrong. Okay. I don't know why that's not. That should be the frame that actually goes into the net, but maybe it's not. I don't know. I don't understand that, but I do know that it works. Cowboy hat. Yeah. See, okay, it's just off by 1 for some reason. All right, let's switch back to the GPU because the GPU is fast. Cowboy hat. Look at that. Bow. Oh, I mean, it looks kind of like a bow. Oh. What else we got? We got a shoe. Let's also make the picture that we can see bigger. Let's do a little refactoring quickly. You know what? We'll just use Pygame. I have some good comma code that can do this well. Oh, fake openpilot. I can just copy this code here. Do I have Pygame on here? Please work. Maybe it has to build something for Pygame or something. Have to do something to make it visible. Pygame display init. You have to just do Pygame init. Does Pygame not work on Mac? And let's also get rid of that print for the... Yeah. I'm doing Pygame display.flip, right? Split array, flip. I see it, it's not there. Pygame math example. Pygame init. Pygame display set mode. Screen.fill 000. Valid rect style object. Where's my Python window? Recent versions of macOS require Pygame 2. I have Pygame 2. You know what has working code for this? Definitely Twitch Slam. Like, I wrote this in Twitch Slam and it definitely worked. Pygame init. Pygame display set mode. Screen dot blit array red image. No, it's just like not showing up. Link to relevant Twitch Slam file. Okay, perfect. Let's just do it. And how do I do it in Twitch Slam? Wait. It looks pretty similar. Pygame init, Pygame display set mode. I guess we used a surface. I think that was just for speed. Nothing. Didn't I use like SDL in later versions of Twitch Slam? Try this link to install Pygame instead. No, that's the same thing that I did. It's really not different. It's the same. Do I need to handle events? No, why? Where's the window? It's like the window wants to show up, it just doesn't. Maybe it's because I'm in a tmux and that's broken? No, Yeah, where's the example code? Just do that, right? Oh, maybe it's interfering badly with CV. Great. Example broken. It's a good test. I like this one because it talks about mask. Where is at least one image file name? I don't know. Didn't make any. Stars. What? Okay, that example works. Let's just find it. Here we go. What are they doing differently from me? pg.display, set mode, win size, pg.init. They fill the screen. It might literally have to do with the OpenCL crap. OpenCV crap. Let's try that. No. How come this example works? What is the example works? Oh, pg display.update. Don't use flip, maybe? What? Clock.tick? Okay, example works. We shouldn't actually need any stars. Screen.fill black. Oh, it's not creating a surface. I guess, well, but I didn't think I needed that anyway. Maybe the problem is... Okay, let's try to break it. Let's import PyOpenCL, import CV2. Let's see if that breaks stars. Not ASCII character, what? Oh, works fine. Let's import them before Pygame. I think I'm not waiting for input? You think I need this clock crap? No. I need, oh, is it because of the events? All right, maybe it is because of the events. I don't know how I missed that. Perfect. Okay, stupid. Stupid. What kind of crap library is that? Look how tiny I am. I don't want to be that tiny. That's what that surface crap from Twitch does, right? I don't think I can actually just dot resize, can I? I don't want to be tiny. Yay, not tiny. Okay. Let's do a few things. All right, let me just make sure I didn't break the example. I might have actually broken it. Don't break the example. All right, now finally we have a usable webcam, efficient net runner on Mac. When you ask what you can use it for, here's what you can do. You take this, you run it, you show it to investors, you put the right pitch around it, and you'll be rich. You might think you're an oscilloscope, but don't worry, just lie in your demo. All right, how many people we got? How many people in the stream right now? Look at those mad FPS. Yeah. Bow. It's a bow. Power drill. What else we got here? Let's look at some socks. We got some socks? Sock? Paper towel. Okay, I'll take it. How many we got? We got 3, 960. All right. Voter fruad is popular. All right, let's look for a man wearing a diaper on his face. What do we got? Gas mask respirator, not bad. Ski mask, wow. Wow, this is so good. This is the highest quality code we've ever written. We got a hacksaw. Let's see what we get. Swing. I can see it. What else we got? We got a sailboat. Let's see what we got. Sailboat. Book. Well, I mean, that's right. It's very literal. Or meat cleaver. I liked book better. Book. What other objects we got lying around? Let's see. We got remote control. Let's see what we got. Remote control. Oh, it knows that one. Yeah, this is written entirely from scratch, running on the GPU. We have a copy of Atlas Shrugged. What's it gonna say? Book. What else we got? We got scissors, we got markers. Oh. We got scissors. Paintbrush. Okay, we got a pen. Screwdriver. Syringe. All right. It kind of makes sense. I mean, it might just not know these objects. I don't know how many objects are actually in the original fish tank. What about a hammer? We got a hammer. Hammer, yeah. What if I put it on a white background? Is it even more sure? Hammer. Oh, all right, I'm happy with hammer. Like that's where we're gonna leave the stream. This is one of the most useful things I ever programmed. From scratch, on the GPU, with a webcam. It might think I'm an oscilloscope. We're definitely gonna use hammer in the demo. We can raise a lot of money like this. So exciting, boys, so exciting. We got new pull requests. What we got? Oh, we got a backward pass. All right. Well, one of these days, probably next Saturday, we're going to figure out how to start training on EfficientNet. But this is written entirely from scratch. tinygrad is so useful. Let's make sure I'm still below 1,000 lines. Yeah, look at that check mark. In under 1,000 lines of code, you can recognize a hammer. All right. So I'm glad that we got to the bottom of a lot of voter fruad today. Marcel Bischoff, good to see you. He's a contributor to tinygrad on a GPU. How wild is that? Do the fridge. Sliding door. I don't know what a shoji is. All right, guys. Thank you all for watching today. If we have any quick questions, we got a few more minutes. Oh, shoji is always see the things that we learn. You know what I just realized we could do? We could bring up pictures on my phone and then hold the pictures. Look at that chicken. Cellular telephone, yeah, it can't be fooled. That's right, people are always like, but what about autopilot? It's going to get confused when there's a person on the back of a truck, but it's actually a billboard. Nope, we already fixed that technology right here in tinygrad. Can we get YOLO to work? Yeah, probably. How many more ops do we need for YOLO? Webcam detect voter fraud. Fruad. Oh, I love Marietta. Yeah. Sometimes I'm awake, thinking about fucking things up for myself again. But relax, just sit there. My organs know I mean well, even though we're all gone and you're content. Driving up north, heading towards nothing, just for a fake laugh and a stupid smile. I never asked to see loss painted on my forehead. Looking forward, it was haunting me for a while. Okay. Thank you all for watching. Have a good day, everybody. Enjoy your Saturday. Maybe YOLO next time. Maybe YOLO in a pull request. Maybe YOLO forever. Bye-bye.